Every day, millions of people drive across thousands of tons of aging steel, trusting their lives to a structure they assume is being watched. But the safety of these crossings depends on a hidden federal report card the public rarely sees. This is the National Bridge Inventory, the central federal database that monitors the structural health of over 600,000 bridges across the United States. While we see concrete and rebar, the government sees a data architecture. A bridge is ultimately only as safe as the records used to track its decay. The 1967 Silver Bridge collapse killed 46 people when a single suspension link failed during rush hour. It was a deadly system failure, but the root cause went deeper than a fractured piece of steel. Surveying the scattered wreckage, investigators realized that the United States had no shared standards for bridge safety. There was no national database, no unified schema for reporting damage, and no way to track which structures were nearing their breaking point. Congress responded with the Federal Aid Highway Act of 1968, which legally mandated the creation of the first National Bridge Inventory. The 1970s version of the NBI was a primitive, flat ledger. Inspectors transcribed observations onto paper forms, which operators then converted into physical punch cards for early mainframe systems to process in slow, weekly batches. This first iteration succeeded in organizing the chaos, but it was a rigid archive. Because it lacked a relational structure, it was incapable of flagging patterns of failure before they became crises. By the 1990s, the government released the NBI Coding Guide. This manual standardized the system, requiring every bridge in the country to be described in the same data language. This schema splits the bridge into distinct fields, evaluating the deck, superstructure, and substructure on a 0 to 9 scale. Despite being relational in concept, data was encoded as fixed-width records. Every piece of information had to fit a single flat line of code. The language was now unified, but this flat format made it difficult to run complex queries or dynamically correlate risks across the national network. On August 1, 2007, the I-35W bridge in Minneapolis collapsed during rush hour, killing 13 people. The tragedy was a failure of action, not information. The NBI database had correctly flagged the bridge as structurally deficient for years leading up to its fall. While the database successfully threw a critical exception, human maintenance schedules and policy decisions failed to react to the warning. This disaster forced a shift to a modern ETL pipeline. State DOTs export standardized XML and JSON data to a central federal hub. Automated validators ingest these records into a hybrid Oracle and PostGIS system, linking every structural record to a precise geographic map location. Modernizing this architecture is about visibility. It ensures that data moves fast enough to force human action before a structure reaches its limit. In 2023, the system underwent its largest overhaul in 50 years, the specifications for the National Bridge Inventory, or SNBI. This update changes how the government views infrastructure. The system now treats each bridge as a multi-layered structural data object. The SNBI architecture operates in 3 layers: XML schemas for validation, JSON for API workflows, and relational tables. These standardized formats map element-level deterioration and precise geospatial boundaries, projecting a digital wireframe mirroring the physical bridge. This object-oriented framework closes the gap between the record and the reality, allowing engineers to track how individual components age in real time. The modern NBI reveals a stark map of national neglect, showing thousands of rural bridges and climate-stressed materials reaching the end of their design life. The database is evolving again to absorb new data streams, including LiDAR scanning, drone inspections, and real-time sensor feeds that create 3D digital twins of every span. Even as the technology shifts from paper to sensors, the core mandate remains the same: to predict a failure before it becomes a tragedy. Today, the National Bridge Inventory functions as the silent, digital foundation that is quietly holding up the entire nation.